start was because it is just getting started, right? I believe it is going to be a very long day. So to introduce myself, I'm Kiruthika Subramani. So I'm very nice. I work in AI. I'm very nice, guys. And other than that, I work as an internal research scientist intern at MILA Research starting from January. And I'm a Google developer expert in machine learning and IBM champion for data and AI. I've written 2 books in AI. My first book is on Gen AI and my second book is on solving various use cases in AI. AI. This is the term you used to hear a lot from me. And other than that, I did it on Do Not Fight talk shows and I'm spotlighted by IBM as today's architects of future technology. And I'm just 21, believe it. I'm new to Montreal. Yes, I have seen Montreal like this, but I'm afraid about this. Yes, honestly. I am afraid of these things. Let's make this conversation two-way, or else it will be like I'm afraid of thinking like it is nobody here. I'm talking alone. Most of the time, my parents in India pretend to be like that when I do Zoom calls for talk shows, like having some mental disorders. Okay, before getting started with our day, let's do one thing. Name yourself whatever you want. So, your name, your right. So you can fill out this form so that you can name a creative name for you. Yes, because this name is like when you open the form, you can able to see the first thing. There are 3 important phrases, which means the favorite color you like, and the next thing is like cartoon character. The third thing is like 90% of you, how you be like. So let me see the responses. Yeah, I'm the first one to complete it. Check. Okay, I'll open the QR once again. If you have any problem, you can. It seems like an exam hall, like everyone are going through. Yeah, I got one. I'm not going to see your name. Maybe the last minute time. Once you're done, let me know. I got 2 responses. They are like super fast. Maybe let's get started in a minute. Then other speakers will be like, what Kritika thought to you all be like, we had a creative name creation today in the session. Okay, let's get started then. How many of you are ready to get started? few hands. Yeah. Yeah, let's get started. So I have given this creative name so that I will ask you a point of view with one question, right? Let's say I'm asking you what is AI. I'll start with your perspective and I'll start to build from that. Is that fine for you all? Yes? Yes? Or else you'll pass the question to me, right? You can just say pass, right? That is the thing I most of the time do in my class. Right. Let's get started. The first thing I used to say is like AI is super easy. Do you all believe me? No. Okay. So the first question I have is for the person who had their creative name. That is Brown Sam Hungry Panda. I like this name. Yeah. The question for you is like, so how you feel in understanding the difference between all these technologies, because they are closely related, right? You want to pass? Or the question is like, we came to know about AI, machine learning, deep learning, Gen AI, and lot of things, right? How would you see the difference in definitions that is provided to us? Do you feel any overlapping definitions when you come across? Wow, he is doing a lot of great things like graphs and everything. I'm very bad at it. Yes, that's good. So, okay, it's okay. I'll take this question as my pass. He's doing very good at software development. Yeah. So, this question that I would like to answer you all is like AI in the sense there are a lot of definition in this world. I'll start with this quickly. So, artificial intelligence is a stimulation of human-like intelligence in machines so that they can act, react without human interaction. I know this definition is not good. It seems like I memorized. Yes, a lot of time I do that. Actually, AI in the sense, the goal of this AI industry is these things. That is, to create machines or any of the systems to do the things that we do. That means mimicking. The term mimicking is always like saying what humans do, but the major thing is like learning, problem solving, decision making, reasoning, autonomy, and the next thing is like self improvement as we do. And other one important thing is perception, right? As a human, we have all these abilities. We have thousands of abilities of our own, but these are the 8 most goals of AI that we are trying to mimic, right? And the next thing is machine learning. As I said, AI goal is also to make the learning more effective. Am I right? Learning more effective. So the thing is like, sometimes learning for us is made by rules, that is called school, college, university, everything, right? It's like set of rules provided to us for our learning, right? Likewise, machine learning is all set of rules, that is algorithms. We give a data, machine use the rules, learn from them, and they can predict for the new thing. That is the thing. And the next one is deep learning is a new approach, not a new approach. If I say new approach, then it seems like I'm born in 80s. So it's like a new approach of 80s, but it is like a self-learning approach. So it's like the machine makes the probability, which means they can predict the probability by passing through a lot of networks. That is what today we are going to do. That is, we are building a lot of models, which means we are going to pass from one model to other model to do that. But this concept is different because it is between a network of neural network. The last thing is Gen AI. How many of you are impacted by Gen AI? Yes. Everything we see in social media is written by Gen AI. Most of the mails we read is written by Gen AI. Do you all accept it? Yes. Yes. Maybe. 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 That's right. Right. Today our world is very much impacted by Gen AI. I will say it's a positive impact because few years ago the problem that made into the development of Gen AI is the single concept, that is, we already had a concept that is web pages where we go and search something where we get a lot of hyperlinks, we'll go through it, right? What about a machine which reads all the trash and give me a perfect output, right? That is the thing that is Gen AI. Gen AI is nothing but it creates a new content from the existing content. That's it. The next thing is LLMs. So about LLMs, do you have any idea about LLMs? That's good. Yes, this is large language model. They are making a very huge impact in the world. So when we talk about LLMs, today we use a lot of them. Let's say Gemini, ChatGPT for a model, ChatGPT Plus, and a lot of things, right? To make our task easier and life easier sometimes. So this large language models work with one concept, that is creating textual data or multimodal data. Most of the times we are aware about one of the architecture, that is transformer. Let me say you a concept. When you say an LLM is more powerful, which means LLM in the sense they read lot of language concepts and they have the ability to generate human-like language. This human-like language can be new generated content, or maybe a translation, or sometimes Q&A answering, and sometimes summary, a lot of things, right? Whatever we do with our LLMs. So that is the thing. So when we say, let's say I want to say ChatGPT is a powerful LLM, what are the terms I can use to describe it as it is a very powerful LLM? Do you have any guesses? Yeah. Okay. You're right. Latency is one of the things, and other things you have accuracy. Yep. And the next thing is scope. Okay. So as you all said, it is like in our approach as a user or something. But when we come into the developer side, when the companies, when you see the launch of all the LLMs, they used to use these two terms, that is tokens and parameters. We have billions of parameters and trillions of tokens. This is the term they use for marketing their LLM at first sight. So parameters, in the sense, it is like the learning ability of the machine. Let's say if I give you 10 pages, right? So you can able to summarize it, or you can use the concept to generate new things, which means you know the keywords, right? Important things from that. That is called parameter learning. So that parameter is more important in order to describe the model's ability, right? Hope you're aware about it. There is tokens in the sense number of words they have learned, right? How much they learned and how good they learned. That is the two things they use. As you all said, it is more important. The next thing is, today when you ask a lot of people in AI, they say we fine-tuned an LLM, and the next thing is like we built RAG, right? I want you all to introduce these terms, because today when we interacting with him, I came to know about he's working on software development. I say they are like even lot of technologies come today. Software development plays a major role. Do you all accept it or not? Yes. Yes. Yes, that is true. Hope you are doing a great job. And the next thing is fine tuning. Fine tuning in the sense, let me say, I work on AI, right? Which means it is a more generalized term, right? Everyone have their own specific domain, right? Which means I cannot say I'm good at everything. Instead, I can make myself good at one thing, which means from the kindergarten to the school life, we will start learning everything, and we fine tune it into one particular task, which is our major domain, what we work. You all accept me or not? That is the thing we do with LLMs. We take an LLM which already have their learning ability, which means they learn from lot of parameters. The next thing what we do in the sense, again we take all the learned parameters with us, and then again we will add it to the next data set. Maybe again we will retraining them on a particular domain, so that let's say if you ask me common questions, I can able to answer. At the same time, if you ask me domain specific questions, I can also able to answer, right? That is the concept of fine tuning. Hope you all understand what I'm trying to say. Fine tuning is like making some tinkering works to say you are good at a specific thing. That is fine tuning is about. And the next thing is RAGs. So before getting started, I want to talk about RAGs as well. But 99% of the task we think we need fine tuning is exactly we need RAGs, right? Because fine tuning is something like it consumes a lot of time and resources, because I'm going to retrain the model. right? Which means I want to invest the most popular term of this era, that is GPU and TPUs. Yes, you all accept me? Yeah, Nvidia is making tons of money, right? That's good, right? Let me say the GPU and TPU is needed, but most of the use case needs RAGs. Let me say what is RAG first of all. RAG is retrieval augmented generation, as you all know. So RAG in the sense, instead of making my model trained by the particular data, instead what I do in the sense, I'll create a database. They will retrieve their answers from the DB, and then again with the retrieved answer they will go to LLM, which means the LLM works in beautifying the answers. That's it. That is what a RAG is about, right? So when we talk about RAGs, you can ask me the question, instead of putting in DB we can train it, right? But for the use cases where the data keeps changing real time, right? And where are the cases I need more factual output, because LLMs never provide us factual output, right? They will sell us stories. Do you accept me? Because it's like they're good at generating the next term instead of providing factual answers, right? So to get a factual answers and real-time response, we go with the RAGs. Instead, if you try reaching out our friends for asking about your lost baggage, they'll be asking your ID, they will track, and your chatbot will be providing the real-time update, right? It's right. It's like they will retrieve from the database real-time and they will get it back to us. That is the difference, because most of the use case not really needs RAG. So when I say the database, it is not actually a DB. So it is what we call as contextual embeddings, which is stored in a place. That is what I'm trying to say, right? Are you all good? Hope you all aware about all the terms that today we are talking about. RAGs, how many of you are confident? Yeah. And the next thing is fine tuning. Yeah. Yeah. RAG is nothing but, so to make it more and more simple, instead of making my model trained, it needs a lot of resources, right? So instead I can put it on a place, my model first retrieve the answer from it, like searching for keyword based or any approach. After that, this context is given to prompt. For instance, hey, I'm Kiruthika. I lost my baggage on 27th. It is coming on the way. That answer is retrieved from there. When it provide an output, it's like, hi, thanks for contacting Air France, and we are delighted to have you a trip with us, like blah blah blah, and my answers. That is provided by the LLM. Hope you understand now? Yeah. So whenever we talk about AI, I feel just terrible because a lot of people talk about the bias, discrimination, and what the term, which means favorism we do with our models. Because when we talk about 99% of accuracy, it's like 1% of the people who are using it is getting impacted, right? So there are a lot of trust cases. That is, the DeepFace is the first database which had all the integral faces of from all the regions, which means, let's say we have a lot of face detection algorithms today, right? Data sets today. But the problem is when we try to train them for detecting the skin disease on the black skin or Asian skin, it is not working. It is addressed on 2017 when people started to talk about responsible AI, how you are responsible. That is why I said I'm nice at first to save me from that. Yeah. So this is the thing that is happening. So government are coming up with a lot of laws. So I hope you are aware about EU AI Act. And next thing is, if you don't build good things, then you will be in prison and also to pay them. And this is the thing that is, we are talking in responsible AI today. That is about building models responsibly, which means there are a lot of principles we are trying to talk, which means the model should be fair to everyone, right? That is the thing one. And the next thing is, when we know the answer, why and how, based on the answer, let's say I'm getting an answer, you are rejected. But if someone is putting a case on a court asking that why he rejected me, my friend is also having the same qualifications, everything, but why rejected? I really want to answer that instead of deploying it in real time, because a lot of people are using that. So it is called modern interpretability and explainable AI. They are like the core concepts, and I'm writing my third book there. and I did my own research there. That means in enhancing clustering, this thing, deep learning. If you want to talk about responsible AI, I'm open to it. And the next thing I want to talk about is small language models. We are still in the impact of large language models, but they have started with next thing, that is small language models, which means whenever we want to run an LLM in an edge device, it is not possible, right? That is because if I want to deploy an LLM in a small device to do a particular task, it is not possible. It will ask me, hey, give me your cloud password. And the next time it will be asking me about, can I know the internet connection, everything, right? If I'm working in a warehouse, not working in a warehouse, right? When my model is working in my warehouse, like I'm deploying it in the sense, it wanna answer some of the particular question, which means I don't need lot of parameters, right? I cannot go to and robot and ask them like, how are you doing and everything. It's like a particular space. Let's say in a warehouse, one of the robot is working in a particular place. They wants to be aware about everything. If one of the employees interacting with it, it wants to understand, right? That is the concept that Amazon is investing on that. So we need small language models, which means it has less parameters and they can work without internet and they can deploy on edge devices. This is the next extent of AI and LLMs. That is small language models. Yes, we are done with all the things. And the thing is, I want to talk about is like when we know in Canada, I know Tim Hortons is very famous. Am I right? Yes. When I arrived, I thought that Tim Hortons is the landmark to go back to my home. In Concordia exit, there are a lot of Tim Hortons. I got confused, honestly. And the next thing is when we say GPU and TPU are the major concepts. So today, let me get into the concept so fast. So hope you understand the common terms, because that is what I want to talk to you first. The next thing is like I want to say, if you have a problem, right, with your model, right, you want to solve a task, right, you are having a problem. Let's talk generally. You are having a problem, or you want to have one thing for the rest of the life. What would you ask God? What would you? One thing. You all don't want anything? No, you are all good. I thought you all answer like this. That's good. But everything, when we try to solve a problem with a model, right? When we build a model, it's okay to build a model and use it within a notebook. But when we come to real-time use case, we do an approach called model training. Model training in the sense we will interconnect lot of models to solve a complex task, right? That is the concept. When first time GPT-1 is released, it works in a concept called chain of thoughts, which means it works with a lot of models and it will retrieve the best answer using the chain of thoughts concept. Which in today's world also, we don't use only one model to solve a problem, right? That is what I'm trying to talk about today. So we will interlink lot of models to solve a problem. That is called model training approach. So when we work with one problem, one model, we get lot of problems. Do you accept it or not? Yes, accuracy will be good, but the precision is bad. But the precision will be good, but when you see the fairness, which means the data distribution, it is bad. But when you work with a lot of models, it is like creating a lot of problems. Yes, but still we want to do that. That is what AI model training is about. Let me say some of the concepts we use in today's world. That is, when you see recommendation systems today, they use a lot of concepts like collaborative, content filtering, and sometimes cosines and like their approaches, like to retrieving and recommending the things. Let's say you buy a butter, then you recommend you jam, and sometimes when you search something in YouTube, it comes all over your internet. When you search something in Amazon, it comes in everywhere you go, right? As ads. This is how they do it. And the next thing is sentimental analysis. Every time when to recommend something, some companies do sentimental analysis, right? Which means how is your emotions? Like they capture your emotions as well. That is like recommendation systems plus sentimental analysis. This model works with two approaches, right? And the next thing is like when you want to say, in some systems you see in a real world object detection approach, you see first they detect the object and then they classify them, like their cards and objects. It's like we are working with, even we can work with one model, but I'm starting with simple approaches, right, to help you understand what this model training is about. And the next thing we all do is like text generation and summarization, which means I generate the text and then I'll ask for the summary, right? And the next thing is like speech recognition and text to speech. These are like very, very simple example of model training approach we use. Hope you understand what I'm trying to say. Yes? Are you all here? Yeah, thank you. So this is the thing I want to say. So it's like there are a lot of routes, right? What is this? I'm aware about it. Montreal's metro map, right? I'm aware about it very well because every time I do this, instead of getting into Montmorency, I'll go into Courtway to go to one station and get back. I think I revolved everywhere. I know this very well. Then I found that from a university to here, there is a bus called 165. It saved me a lot of time. Sometimes I do that. And the next thing is like, let's get into some of the complex approaches we do. That is one of the things is, first they will detect your disease and they provide recommendations. Today a lot of bots do that. And the next thing is like fraud detection and then their prevention, which means outlier detection we do. It's like the two tasks, two different models, but they are chained, which means one output is provided to the output of other. Hope you are aware about the gradient boost or XGBoost algorithms. They work by this approach, but they are within that algorithm. Now I am coming out of that algorithm. That is the thing. Now let us get into our topic. Yeah, you talk too much. That is what you people thinking about me. Yes. Okay. Hope you can open this data set, scan the QR, understand the data. Before starting into any task, we want to understand our data really well. So I want you all to see the data set. How you all feeling so far? I feel you are like, oh no, we are in the wrong room. Am I right? Okay, have you all scanned this? Okay. Is there is a data set? I'm believing my online free QR code generator. Yeah. Once you are done, let us understand our data. How many features we have here? 7. Okay. So let us understand. I'll talk about responsible here as well. So which is the sensitive attribute? We cannot predict based on that. Sensitive in responsible AI, we call a term called sensitive attribute, which is related to the demographic information of an individual. Let's say I cannot recommend a job to a person based on their what is it? H3, H2, and pin code, zip code, right? They will be pissed off at me, right? So that is the thing. So here the sensitive attribute is age. Whenever we build the model, we want to see our model is biased towards an age, because in the prediction level, whether my model is getting memorized with age and predicting others or not. This is a sensitive attribute here. When we build the model, first of all, we want to identify sensitive attribute. Come on, we are in responsible AI era. There are a lot of laws. Yes. Okay. So today we are going to build. Let me say you. Okay. Let me say you why age is a sensitive attribute here. I'm not mentioning a term critical sensitive attribute. So when it is related to a demographic information of an individual, let's say the age, right? I cannot provide some medical recommendations based on their age. Instead, there are a lot of, I'm saying that my entire prediction does not want to depend on that only one, right? So let's say if my model is making one prediction, I run a feature importance, which means it shows which feature is more important in prediction. If it is only biased towards age, then we want to work on our model again, right? We want to assign it as 0, right? The entire prediction should not be from age, right? The contribution from age should be less. That is what I mean. Is that fine? Yeah. Okay. Let us get into our model. See? That's okay. Okay, when you upload this data set, hope you all have the data set with you. I will share this notebook to you as well. Now my runtime is getting disconnected because I'm not a Collab Pro user, right? Yeah, let us understand what I did first, right? The first thing in risk assessment is what? Risk, right? I want to find the risk, right? Then only I talk about assessment, right? First, let us find the risk. You have the data with you, you understood the data really well now, and I've shown you some metrics as well. Now don't ask me why sugar is in this less metrics. It is an MMGODL, it is not an MGDL, right? So that is the difference in the data set. I downloaded it from Kaggle, right? So it is a very big repository. Yeah, the first thing I'm trying to do is like I'm going to build a risk assessment model, which means an ML model. Then if I use a model, you will all ask me one question, maybe this would have worked better, right? Right? Sometimes it took a lot of time for us to find the best model, right? Like finding a best pair of light. It is an indeed. Okay, let me say here what I did in the sense to make you clarify. I used all the classification models and then I'm going to choose the best one from that. Is that acceptable from you all? Right? Yes. Thanks for accepting that. Our runtime is getting disconnected. Okay. Hope you have any questions in this. You can ask me. Do you know what is joblib? Yeah. I started this question because when I say what is pandas, you'll be like, it's not a kid class, right? So joblib in the sense it helps to save your model, right? So let's say I'm running 10 models or 11 models. I don't want to again and again call the variable, right? Instead, I can store it. I can use that, right? As a pickle file, PKL file. So for that, I'm using joblib. Hope you are aware about other things. So based on this, can you please say what are the models I'm going to be using here? Random forest, random classifier, fine. XGBoost, gradient boost, logistic regression, decision tree, that's it, right? What is label encoder? Yeah, so instead of doing one hot encoding or label encoding from our own, I'm using one of the module that is label encoder. It will help me to convert the process much easier because my task is not to build only one model, right? So whenever we experiment model, use this approach maybe, and I'm using the data set. I swear to use the same data set, right? And the next thing is like every time we do, the first thing is like to search the missing person. There is no missing person because I took it very clear, right? We want to treat it like a hell. So that I took without a missing persons. And the next one is like feature distribution. It is like to see, let's say I'm going to build a medical data. I'm handling here a medical crucial data, right? I want to see the distribution of data first of all. Let's say if I have only data between 18 to 25, then I cannot say I built a model for everyone, right? So that is the thing, I'm going to visualize the distribution first of all of my data, right? To see whether my model is skewed towards a particular value. Or else I can add it as like, hey, hi, see here, I do medical pregnancy risk assessment for 18 to 25-year-old person. I want to literally call like that, right? So I'm going to do that. And the next thing is like about the risk levels. We have 3 risks. When you go to the column, you can see 3 risks, that is high, moderate and low, right? Just you can see the data set. We have 3 risks and I'm going to see the distribution of them. And the next thing is like when you see the boosting algorithms, always take numerical thing, right? Hope you understand. Numerical thing in the sense all the data should be in the numerical format to process because they are working in a chain approach of trees, right? So what I'm going to do is like I use label encoder to convert my risk level because risk level is categorical here. All the others are numbers in this data set. Am I right? That is the reason I'm particularly using for that, right? Can I know how long? I think we are running time, so I'll make sure yes, we will do it on time. This is how I'm confused, right? And the next thing is like every time when we want to build a model, I cannot give all the columns in training, right? Then my model will memorize it, right? So we want to have what is the predictable and what is the learnable parameters, right? So that is what in test set, right? So that is what I'm doing here as you do. What is the distribution of this data here? How much training and how much testing? 30% testing. About training? 70%, so 100%. And what is this? Every time people used to say random state equal to 42. Yeah. Why always 42? Yeah, the thing is like when you try to run a model, everyone want to get a consistent output. If you want to try to recap, do whatever they want to do, to get a consistent output or a consistent process, we go with 42, right? Whenever you share this model to someone, most of the people use 42. It's like to get consistent output among everyone. Else you can use any number you want, or else as also 0. As she said, it's very right. And the next thing is like I am looping a dictionary. So this dictionary has all the models, right? Dictionary in the sense key value pairs, right? I have everything and have given all the metrics, right, to run this model, right? Hope you see all the models are present here. And the next thing is like I'm going to save all the model performance as the next dictionary because I want to show you, right? And the next thing is like I'm fitting with my data. So for the accuracy calculation, I'm going back. So can you say me what are the accuracy metrics I'm using here, which means to calculate the performance? ROC, what is ROC? Yes, it is area under curve. If it is close to 1 in the sense, the classification happened really well, which means the two class are splitted really well. That is what AUC, which means area under curve and AUC, or you say about. And the next thing is it should be close to 1. And what are the other metrics? Accuracy score. And other thing is I made one thing that is here you can see classification report, which brings you precision, recall, FN score, everything, right? It is you can call everything as one. Okay, then done. We built a model. Let us see. And I evaluated the performance. And see here, I did one thing. For the fairness analysis, as I said here, the sensitive attribute is age. My model cannot be skewed towards a particular age or towards the age column. So I'm going to test that. And other than that, I'm going to see the risk level based on the age group. Let's say my model don't say like 50 to 60 when the people are aged, their pregnancy risk is high, as we know. But the model does not want to get biased with its data, right? It need not to be an early prediction. It needs to go to the chain and make that prediction. It should not be early memorized predictions, so that we are making sure that. And the next thing is like we plot everything. As I said, this job lib is helping us to save it as a model, right? I help you to walk you through the code. When you run it, it would be very smooth, I swear. Yes. Hope you understand what we did now. It's like we build a risk assessment model, right? Models, right? Let's find the best model now based on our output, right? So do you have any questions here about our model building process, right? Because here I'm not choosing any one model, right? I run all the model and I want to choose one. I'll show the output and we will choose the one. Are you all sure about this process? Let's go with the next. So actually I haven't did any feature engineering approach because the first thing is I took a very clear data. When you see the data, the feature engineering approach we need in this entire process is only one thing, that is encoding, the last column. Because for trying out the task to make it easier, we cannot dive a lot of time in feature engineering, I get that. But in real world problem solving, cannot be given answer as well. Right? Okay, let us view this output. I'll open it into, unfortunately I haven't given a clear output screen in a condition, right? And it would be a problem. So this is the entire output I got by running that cell, right? Let us see. The first one is the answer for description. I used to describe function of pandas. So it is describing my numerical attributes. So we want to understand the first thing, count, which means the number of values we have. Mean is the average value, which means what is the most common average value we have. Standard deviation in the sense the variation. right? Let's take the most of the common variation between data. Let's say 17 or something, 13. And next one is minimum, maximum, every value. So just plotted to see the difference, whether the data is skewed. This output will help us to understand whether the data is skewed, right? But in our case, it is perfect because we are going to do pregnancy risk assessment. It is not, the average age is 29. It is not showing like 5'4", right? The age is 5'4", it is not acceptable from our side. Then we are doing that. And the next thing is like missing values. I'm so cleverful here, right? I chose a data set without none of the missing values. So our data is perfect. The next thing is like, this is a feature distribution. Let me say, this is the average feature distribution. Hope you all understand this chart, what it is meaning. How many of you say yes? Okay. The question is for you. Then what is 50 percentile here? 50 percentile value in this chart. Here, this line. So let's take 25, 50 and 75, right? It is based on the value, it cannot be equal, right? We cannot split it equal. And most of one case you can see, you can ask me one question here. Why there is no value, medium value? Because most of the value ranges between a particular thing there. That is the reason. And the next thing is like, when it goes out of the whisker, it is like the errors, which means not errors, it means outliers, which means they are not following under some distribution, right? If we face some problem related to this model, maybe we want to treat it here. That is why we do this visualization, right? I would help you to walk you through machine learning as well. Hope it is fine, right? And the next thing we do is like, we see the risk levels. Yes, of course, people with low risk is high. That is very happy thing. And the next thing is, let's see our model performance. Logistic regression 63, and see, ROC AUC curve should be close to 1, which means here 80, which means 100, right? It should be close to. Most of them are good. They are splitting really well. 80 is not a good score, but it's fine. Can you know what is macro average and weighted average? When you run a lot of models in your life, you get to see when you use classification metrics directly. What is that? Yeah. So macro in the sense, it will treat all the thing as equal, which means all the group as equal, which means 0, it starts with 0. Weighted in the sense, it will assign weights based on the number of columns or rows or number of things they have. That is weight. We assign weight and calculate, and the thing is like without that, right? It will help you to look into the error. When you face some problems, you look into that. That is the reason. And the next thing is, we have a lot of performance and we are finding our best model. Yes, our best model is XGBoost, right? Here in our case, XGBoost works really well. And the next thing is like, I'm seeing the feature importance. So as you said, one of the people asked me why we call it as a critical feature. If I'm right, he asked me, thank you so much for this question. See here, in my model, age is contributing very less in the prediction, which means it is not contributing, doesn't mean it's not contributing. The most of the prediction depends on the systolic blood pressure, which means when I predict, my model learns something, which means the internal learning shows it systolic BP is providing a lot of information. That is why it is more important to see the feature importance when you build model, because we are in responsible AI era, right? And the next thing is like, I'm seeing performance based on the age group. When you see, when your model is not particularly working for a particular group, which means the performance attributes, because you have less number of data between that group. That may be a reason for the less performance, right? So you can use this notebook anytime you want to build model. So you can inspect, cross-inspect your model, because it's like a proper way of building a model, right? Machine learning model. Is that fine? Do you all accept it? Yeah. Okay. No. What I meant is like, so when we see the age distribution, so see here, it starts with 20. That's a fine age of pregnancy, right? I cannot say 10. Let's say my data set has some irrelevant ages, like 10, and we are doing some, they also have their BP value, everything. When I give these values, My model want to say it's an irrelevant data first of all. It cannot predict the pregnancy risk, right? Because here whatever I give is like only the data, BP, everything. Every one of us have the BP, right? The thing is like the age, right? That is what I mean. You are describing here. That is the describe function here. I meant that, right? That is 10, right? You are meaning here. Yeah, see here, what I want you to say you here is like, when we make predictions based on the particular data, most of the time it will shade as low risk, so that I'm cutting down that. So what I'm trying to say that is like, when you do feature engineering process as he meant, whenever we are building some mean model, we want to cut out some data. It's like 10, 12. Some people even have their pregnancy problems in 10 as well. So that is like cutting down of data based on our needs. So it's like to see the skewing of data, which means 10 to 15 or 15 to 20, we see the distribution. But when we come to the distribution level of 10 or 8, as you said, they are coming under the section that is outliers, which means they are not falling under a particular thing. To explain it clearly, when I did the box plot, you can see it as an outlier, which means they cannot fall under one relation. You can see them down, which means it is very less age, right? That is, we calculate it as an outlier. Outlier doesn't mean error, which means one abrupt value, right? Hope you understand. Yeah, that's good. Let's get back. Our model building process is done, and the next thing I'm going to do is like, I'm just going to use some of the HTML features to just to show you the observed accuracy only. So see here, I just plotted the feature values in the model observed accuracy. As you know, based on our observed accuracy, XGBoost is performing really well, right? Right? Yes. Because this time you want to accept me, because we did one thing, we evaluated the best model using best approach. Hope you all agree or not? Yeah, thank you. And the next thing is like, what I'm going to do is like, most of the time when you want to interact with your model within the notebook, you can use this feature called Jupyter Dash or Grad.io, right? You can give input and check whether your model is working good or not, right? Grad.io, have you ever used Grad.io or Jupyter Dash? They work really well, because you don't want to build your front end or back end outside your notebook, because they will disconnect the runtime. Right? So I'm just so to understand this, Jupyter Dash and Bootstrap in the sense to add some design features like colors, choose that, we want that. And the next thing is like Plotly. Plotly is to do interactive dashboards, which means you want to type something there and you want to get outputs like something interactive, right? That is what we do. And the next thing I'm gonna do is like, I'm gonna build a dashboard to first see the predictions, right? Do we do that? Yeah, I feel you all are feeling so sleepy, right? I feel it, you can see it here. Okay, so let's start with the fun names then. I want to ask you one question. What one thing you feel like that is the dominating, can you describe, maybe let's start with the question. What is the 90% of you in your life? I'm like a last minuter, and do any one of you want to say about it? It's a secret, right? We don't want to reveal it. That's fine. Okay. Okay, let me go directly into the dashboard we built. Okay. The first thing, the same code, what I did is like, the first I built the dashboard with only making predictions, and the next thing I did is like, I added summarization, translation and other features like adding some models. That is our goal, right? Let me summarize it quickly. So it's like, I'm loading my model. Yes, it makes my prediction that is high risk or low risk. Yes, we did it. And the next thing is like, I'm analyzing the sentiment. I'm asking the user to enter how they are feeling, right? If a pregnant woman want to enter how they are feeling, based on that, if it says negative, we will suggest them to reach 811 because 911 is very busy, right? So I'm asking about their sentiment, which is the second model I'm using. For sentiment, here you can use any model like Gemini or GPT-4, anything. Here I'm using Distilbert because it's a very small model to learn, right? You can use any model you want. And the next thing is, this is the second model in our chain. And the third model I'm using is like I'm getting user output. It's not a model, which means I'm getting the user output. As I said, the thing is like age, BP, everything, what are the features I want, and then I want to make prediction, right? For XGBoost, I want input, right, to make the prediction. That is the second is sentimental analysis and their report. That is the two model we used. And the next thing is like we use that UI enhancements like using Grad.io, which means we want to make it more interactive. And before that, we used another one thing that I wish you to share. That is the thing, when we go for one of the pre-trained model, you face this problem. At last I want to talk about it and I'll share you this notebook. That is, whenever you want to use a pre-trained model, you want to make sure to use very small fine-tuned pre-trained models, because it might increase the latency, because the user who want to interact with your dashboard don't like it to load for a long, right? So maybe that is the reason I used Distilbert, because Gemini is taking around 4 to 5 minutes, and you can see the next dashboard I used Gemini, right? When you deploy this dashboard, it is live for 2 hours, right, in Grad.io if you don't sign in. So that would help you to see how this model runs, right? If you have any questions, I'm running out of time. So if you have any questions, you can ask me. I'm here the outside. So if you want to talk with me during a break, you can. And if you have any questions, you can ask me now. The last part is like, the first thing is like I did is I built an XGBoost model in a detailed way, and I just added a pre-trained model to analyze the sentiment. That's it, right? It's like a model which goes as a chain in loop, right? You can add how many you want in chain, right? I have added a lot of features. You can see it's a detailed notebook. And you have any questions today? How you all felt? Great, honestly. Yeah, I believe. I will hear from that about coffee chat. Thank you so much for taking time. Yes, have a good day, guys. Hope you will be having informative session.